Here's the second example, and we're not going to do it by hand this time, okay? We're going to use the calculator to fully do the problem. It wants us to find x3, okay, the third iteration. So, if you recall from the previous video when we did it on the calculator, the first step is we need to enter this into our y equals. On my calculator, I have it entered into y2. You could enter into y1, that's fine. And then we need to take our initial guess and store it into our x variable. So I'm going to hit 2, I'm going to hit the store button, and I'm going to hit X. So that's going to be 2 arrow X on the calculator, and that's just going to store 2 into here. So now 2 stored into there. Okay, so now what we need to do is just type on the calculator Newton's method. So that's x minus y1. I'm doing it for you guys if you store it into y1. Parenthesis x, close the parenthesis, divided by, now depending on what calculator you have, d by d has a little box, I'm going to hit x, has parentheses, I'm going to put a y1 there, and it has an x equals, I'm going to hit the x button. If you have the other way, all this is the same, it's going to say n deriv. You're going to put in y1, comma x, comma x. And then in either case, you're going to store it, so hit your store button and put an x. If you type this exactly in on your calculator, you have it typed in correctly, this will do Newton's method for you. So, upon doing this, let's see, give me one moment, I gotta type it in on my calculator. Okay, I'll show you what my calculator looks like. X minus, now mine's stored in y2, yours could be stored in y1, just pick whatever one it's stored in, of x divided by, I have the top one here, so that's why it looks like that, x minus y1 of x divided by that, of y2, because mine's stored in y2, of x equals x, stored into x. And if I hit enter, I get my x2. x2 is equal to 1.5, 5, and then hit enter one more time, you get x3, which is 1.5215. Now if you keep hitting enter, as you could see, after like 6 or 7 hits of the enter key, the number stops changing and it stays at 1.52179707. Okay? You could see this line and this line are exactly the same. If I hit enter one more time, the same number pops up. So it didn't even take a lot of entries to get it to go to the actual answer. Okay, so we could calculate as many iterations as we want. As you'll see in the next examples, it says correct to 8 decimal places. Okay, so let's go ahead and do one of those. It's approximating a number. It says use Newton's method to approximate the given number correct to 8 decimal places. Alright, so the fourth root of 100. Now we know square roots pretty well. How about fourth roots? Okay, let's think of around what number this could potentially be, because that's what we're going to use for an initial guess. So I could rewrite this as the square root of the square root of 100. Okay? Let's think about why this is. The square root of the square root. This is 100 to the 1/2 power, all to the 1/2 power. Okay? If you remember how to do powers to powers, your exponential rules, you multiply the powers. 1/2 times 1/2 is 1/4. Well, this is the same thing as the fourth root of 100. 100 to the 1/4 power is the same thing as the fourth root of 100. Okay, so we can get an estimate of what this could be. Well, the inside square root, the square root of 100 is 10. Now, square root of 10, we're going to approximate it. Square root of 9 is exactly 3. So square root of 10 should be approximately, I don't know, just take a guess. I'm going to say 3.1. Something a little bit above 3. You could use 3 as an initial guess. That would be close enough. But let's say we're going to use 3.1. So we're going to say 100 to the fourth root of 100 is approximately 3.1. Now, what we need to do is we need to come up with a function that models this number right here. And it's going to be x to the fourth minus 100 equals 0. Let me show you how I got that. What I did, all I did was take x and set it equal to what I want. And now I just need it to be equal to 0, but I don't want any roots in there. So I'm going to raise both sides to the fourth power. I get x to the fourth is equal to the fourth root and the fourth power cancel. 100 minus 100 minus 100. So, and then it brings you up to right there. So solving for the roots of this equation is equivalent to finding what the fourth root of 100 is. Okay. So now we know what our function is. We have our initial guess. Our function here is x to the fourth minus 100. And our x1 is equal to 3.1. Enter this into y1. So y1 on your calculator, you're going to enter in x to the fourth minus 100. Then you're going to store 3.1, store that into your x value, just as we did before. So 3.1, store that into x. And then you're going to type in Newton's method. So x minus y1 of x divided by d by dx of y1, x equals x, and then you're going to store that into x. Or the other way, and derive of y1, comma, x, and then you store that into x. And then you just keep hitting enter, and it wants it to correct to 8 decimal places. The reason why it says 8 decimal places is because that's how far your calculator goes out to. So Let's go ahead and write our numbers here. So type this in onto your calculator. We've got our x1. x2 is 3.1641. Hit enter again. x3 is 3.1622. Hit enter again. x4 is 3.162277. Oh, it says correct to 8 decimal places. I know I'm truncating these, but the digits after that. Oh, look at that. If you hit enter one more time, the fifth iteration, it does not change. 6.16227766. If you see the iteration before, which was our fourth one, and our fifth one didn't change. So it got to the 0 pretty quick. Okay? So what we can say is the fourth root of 100 is equal to 3.16227766. Let's go ahead and check it. Type in on your calculator 100 to the 1/4 power. 100 to the 1/4 power. Hey, look at that. It equals exactly that. So before calculators were invented, it was troublesome calculating numbers like this. This is a really weird number right here, okay? They could get estimates just by sitting there, trial and error. Like we said it was approximately 3.1. That was a really good guess. And then what we could do is square this number and see how close we are to 100. Or sorry, to the 4th power and see how close we are to 100. And then keep doing that, then it's going to be a little bit less. So we tried maybe 3.2. It's going to be a little bit over, and we're estimating. But using derivatives, it gives us a lot faster route, a much better, quicker route than if we were just to keep guessing every time. Okay? Now, you should go ahead and try the next problem. It's the 4th root of 27. Okay? The 3rd root of 27 is about 3, so the 4th root of 27 may be a little bit under 3.